Hello, welcome to my channel. Today we are going to do the dimensional equation. But before studying dimensional equation, we have to learn about the basics first, so we can get what are dimensional equation and why it is useful. So dimensional equations and the basics consist of units, and unit units are the way in which the physical quantities are measured. So just like mass is measured kg in SI unit, we are going to talk about in SI units, all about, not in CGS units. So mass is measured in kg, and length is measured in meter, and so and etc. We can measure, and there are 7 fundamental units for which we have different units assigned. So time is measured in seconds. So physical quantities like force, momentum, and other physical quantities are measured. First we should learn about for 7 fundamental units. So the 7 fundamental units are mass, which is measured in kg, length which is measured in meter, time is measured in second, and the fourth one is temperature, which is measured in Kelvin. Fifth is amount of substance, which is measured in moles, and the sixth one is electric current, which is measured in ampere as we know it, and the seventh and the last one is luminous intensity, which is measured in candela. Equations. So what are dimensional equation? Basically dimensional equations are the way in which we can understand how a physical quantity is dependent on its basic fundamental units, like force force is dependent. Force, we know the formula, mass and acceleration, but do you know how it is dependent on length, time? We can clearly see it is dependent on mass directly, but we don't know how it is dependent on length and time, how it is related. So to study about how the physical quantity is related to basic units, so dimensional equation are nothing but symbols, nothing but fundamental quantities which are raised to the power. So if we are gonna consider m power 1, then it means that the the physical quantity dependence to the power 1, that means it is directly proportional. If it is -1, that means inversely proportional, and same goes for all other physical quantities, all other fundamental quantities which are mentioned here. So let's start solving the questions, as we can understand more clearly when we solve the questions. So let's take first force itself. We know force is equal to ma. ma formula. So what is mass? We can so mass is taken as symbol as m, and length is taken as l, time is taken as t. As and we also should mention some rules, which is to signify the dimensional equation we are going to put the square bracket of the physical quantity, which denotes the dimensional equation. So m, so mass, we have assigned the symbol m, and for acceleration we know that it is distance traveled by time, squared. So which means distance is measured in length, distance is a length physical quantity, and time is t, which is squared. So we are gonna substitute it here, that is ml m power 1 l power 1. When we take it to denominator, it works in the same way as other as we can, as in basic mathematical rules. So when we take it to numerator, we get t power minus 2. So the dimensional equation of force is m power 1 l power 1 t minus 2. Let's solve some basic questions. Let's take let's first consider some of the generally used physical quantities, like energy terms, like potential energy, kinetic energy. We know energy is nothing but work, and we know that work is equal to force into displacement. We know the unit of work is joule. So the unit of energy is to joule only. So the unit of dimensional quantity of energy is, or which can be taken as work too, is, as we know, force we have founded mlt minus 2, and distance we know it is l. So when we do the math, we can use here basic maths, which can be base are same for l, base are same, so powers are added, that is m1 l power 2 t minus minus 2. This is the dimensional quantity of energy. So let's take another question. So consider this formula, which is used for finding the heat transfer in a solid. So consider we have to find the dimensional equation of k, which is a constant. So first we have to simplify it. So let's simplify it. Q into d, and a to denominator with theta 2 minus theta 1 and t. So before starting to find the dimensional equation, we have to know what are the terms given here. So what are the physical quantities present here? Let's Q is energy, T and D are length, and A is the area, which is length squared, and theta 2 and theta 1 are the temperatures. So we know that we know all the dimensional equations of all the quantities given here. So we can start finding the dimensional equation of k. So dimensional equation of q is, we have founded here this m1 l2 t minus 2, and dimensional equation of d is l, and the dimensional equation of a is l2. Dimensional equation of theta 2, which is temperature, we know that it is Kelvin, that is k, and theta 1 2 is k, and t is the length, so it is l. So first, as we have mentioned the rules before itself, that when when we are subtracting the, as we are not considering magnitude here, we are just using the units. So when we subtract the units, it will be the same unit itself, or if we add, it will be the same unit only itself only. So L power 3 bases are same, power are added for length, and for k minus k we get k only, as it doesn't have any relation with the magnitude, it is k. So we have to simplify it to find the final answer. That will be, yeah, m L power minus 1 t power minus 2 and k power minus 1. Sorry, t is not length, but it is time, so it has the unit of t. It has units of time, so that is t, that we have to correct it, and L power 2 t. Now we have to solve it. Then finally we get the answer as t power minus 1, which will be taken up, and it will be L, and this cancel, so we get only L, that is powered plus 1, and t power minus 1. Then we solve it, we get m1 m power 1 L power 1 t power minus 3 k power minus 1. So this is the